All right, stats. Here we are with a possible notes video for Wednesday 2/19. If we are in person, then it's just gonna be a notes video for anybody that misses or needs to catch up. But if we had an e-learning day today, I'm just gonna preemptively make a notes video just in case. All right, so because we're gonna look at our chapter 14 notes packet, page 16, 17, and last pages example. So page 16 and 17, examples 1 through 5, plus the last pages, plus you never know. So let's have some paper out. All right, here it is in your notes packets. Yeah, all right. Confidence intervals for population proportion. So here's the key formula. And that is p hats, that's p hats, is plus or minus z star, and then in the square root, p hat times 1 minus p hat over n. P hat is the sample proportion as it says on the right. Now, with confidence intervals for population proportion, we use z star all the time. So that's pretty sweet. Don't have to look anything up on a t-table. Guys, you've seen this before with polling and then margin of error, so it's going to be hopefully something you've got an idea about. Anyway, in a sample of 1,035 voters, they were polled about which 3 candidates they're going to vote for. So candidate 1, won the sample, won the poll. 448 chose candidate 1, 394 chose candidate 2, and 193 chose candidate 3. So we want to create a 95% confidence interval for each of them. Now, it is true that candidate 1 won the poll, which is just a sample by 54 votes. But let's find out what we can really say. All right, so P1 hats, you can just say P hat if you want, is 448 over 1035. At first I did candidate 2 on accident. We always round proportions to 3 decimals. Guys, you're going to be marked if you round proportions to 2. We just can't round to 2. All right, we got to round proportions to 3 decimals. 433, it does make a difference. Candidate 2, 394 over 1035, that's 0.381. And then that's candidate 3. Okay, so we're gonna use that above formula. I'm gonna show you 1 and 2 here in a second. Don't worry about the whole overlap thing. Okay, so how do you type this in your calculator? Well, guys, I think you know. I kind of go old school with it, but if you wanted to, so again, mode, math print's gonna be great. If you wanted to type it all in, you can do square root and then have n over, you can say, oh yeah, n over d, not PRB. I just type it in like this, Type in 433, 567, down below 1035. Great. Go over here, hit enter, and then multiply. An error a lot of kids make is they don't multiply by 1.96 on the outside. Multiply by 1.96, 030. Again, that's what you're doing. You don't need to write 1 minus 433. Just figure out what's the complement of 433, and that's 567. All right, add and subtracted. So candidate 1 did poll at 43.3%, but the margin of error is 3%. So in the population, everyone that might vote, it could be as low as 40.3%. They could be as high as 46.3%. All right, here's candidate 2. Now, because they polled at relatively the same proportion, they're off by 5.2%. Same sample size. We shouldn't be shocked that the margin of error is exactly the same. I mean, rounding, it's a little different, but so candidate 2 could poll at 35.1 on the low one, but then at 41.1 at the high end. That's pretty interesting. And candidate 3 definitely did not win, but maybe candidate 3 qualifies for a debate if they're definitely above 15 or if they can hit 20%. So let's see, do they have a chance of getting to 20%? Anyway, their proportion is definitely much different than the other two. So their margin of error is less because their p hat is small. So it's not a ton of wiggle room there. I mean, it's much closer to 0. Or, in the other case, if something is really close to 1, you'll have a low margin of error as well, possibly. All right, so 0.186814. Their margin of error is 0.24. So at the bottom, they could be at 16.2%. So they should feel good. They're definitely pulling above 50%, 15%. At the high end, it's 210, so they could hit 20%. Anyway, here's what it's about candidate 1 versus candidate 2. So what you do is the person that won the sample, you look at their lower bound. Talked about this in yesterday's notes. So 0.403, and then whoever like lost the sample, not candidate 3, they were way behind. But candidate 3, you look at their upper bound. So because there's overlap, because what they could do, again, this wouldn't be an outlier. Like this is in their 95% confidence interval for the population proportion. They could potentially be pulling at 41.1%. They could potentially be pulling at 40.3%. So they could potentially, it doesn't look great, but they could potentially actually be pulling higher. So because there's overlap, there's no clear winner. Candidate 1's not feeling terrible about it, but candidate 2 could say, hey, we're within the margin of error. So if somebody says they're within the margin of error, that means there's technically no clear winner. Willie Decker and Palmer Jones. Lovely names there. Shoot 150 free throws. Willie makes 117, Palmer makes 124. Like going forward, what's a 95% confidence interval for their population proportion? Let's say it's an early start to a season. With Willie here, 117 over 150. That's their current proportion. That's a very small sample size, 150. So the margin of error is going to be pretty big. So they could regress down to 71.4%, or they could turn it up and they can eventually shoot 84.6%. All right. After many repetitions. And we have Palmer Jones here. Did better in the first 150. They could regress, though, to 76.6%, or they could go all the way up to 88.8%. So if they end the season within, anywhere in that confidence interval, we're not going to be shocked. Not going to be shocked. Again, pause this whenever you need to get these answers. These are relatively quick. Relatively quick. We could learn this new thing in a notes video. The EPA considers indoor radon, talked about that the other day, about 4 picocuries per liter. Anyway, of air to be high enough to warrant amelioration efforts. All right, that means you got to get that little contraption down. I've seen it once. Tests in 200 Center County, Pennsylvania homes found that many have a level that's an issue. So let's make a confidence interval, 95% confidence interval. They gave you p-hat, so we're ready to go. Get in your calculator if you want to do. You can type it in exactly as I showed you. You can also do 0.635 times 0.365, hit enter, divide it by 200, do square root of answer, and then immediately multiply it by 1.96. All right, and you get a margin of error of 6.7%, 0.067. So it could be up to 70%. Up to 70% of people in the county could have it. Okay, all the way down to 56.8, which is still not great. Still not great. Okay. We've got Yogi the old dog as a visitor here. You'll hear him. He's making the old dog sounds. 386 of 17 people who voted for candidate A are college graduates. There's a little bit of a glare there, but it's a quality you come to expect in Yak Math videos. 371 of the 1,245 people voted for candidate B are college graduates. Create 95% confidence interval for both. I guess someone definitively winning the college vote here. So candidate A, that's the sample proportion. Plus or minus 1.96. P-hat, 1 minus P-hat over 1517. So the margin of error, as it increases, the margin of error decreases. All right. That's A's confidence interval. And then we look at B. So B in the sample here, B has more of the college vote. But, take a look. So A came up, shorter, had a lower p hat from the sample. So we look at their upper bound, we look at their lower bound, and there is overlap. So technically, like, it's within the margin of error. Definitively, we can't say that B is definitely getting is winning in terms of getting the college vote there. They're within the margin of error. Very close to call there. All right. It's all about being within the margin of error. It's a little dated, but 2017, 29%. So we're going to use a p hat of 0.290. Now, they would have had to do some rounding, so it might have been like 296. If you take 0.29 and multiply it by 1020, yeah, it'd still round down to 290. So we're gonna assume it was that. All right. Surveyed, approved of the new tax changes of that year. Create a 95% confidence interval for the true proportion. Margin of error is 0.28. So, like, it could be 30%. Okay, it might be 31%, might be 27%, could be right at 29% of the true population approves of those measures. Okay? So, those first 5, and then we got a few here at the end. All right. And when I mean end, I mean we're go to where the very back few pages that I hand wrote. It says pre-quiz questions. 25 students in a certain senior class were randomly sampled and given an academic test. Their sample score was a 71.09 with a standard deviation of that. Construct a 95% confidence interval for the true mean score of the senior class. Randomly selected. All right, so 25, guys, and this is a mean. 25 is less than 30, so it's T-star time. All right, go to your T-table, 95% confidence level, degrees of freedom 24. T-star is 2.064. All right, the margin of error then is 3.71. So could we expect an average, just sampling those 25 students, could we expect an average of 75? Probably not. Again, if it's a true sample. Random sample, that is. All right, interesting. We're not really asked to give opinions. I mean, we can say, like, look at this. The true average is probably not going to be 75. It's probably not going to be as low as 65, that sort of thing. All right, so we did the car company in a video for last Wednesday. Candidate W received 673 out of 1,200 votes in a recent poll. Can they feel absolutely confident they're receiving a majority of the support? Absolutely confident. All right, so that's a big question. Absolutely confident. Like, they're going to feel good about getting 61 or 56.1% of the vote, but absolutely confident. 99% confidence interval. That's a Z-star of 2.576. There's the formula. What we get for the Mo is 3.7%. Because it's at 99% confidence interval. If it was 95, it'd be less. Anyway, look at that lower bound. We want to look at the lower bound because they tested above. So obviously the upper bound is going to be above. But even at the lower bound, that's 52.4% of the vote, which is still a majority. So yes, you should definitely feel confident about what's of having a majority of the vote. All right, so I believe we have one final question, and you guys hopefully did well with your little assignment you saw in the other video. So this is going to be it. It might just serve as an extra notes video, or it might be another eLearn Today video. 741 out of 950 patients studied saw a medically significant decrease in inflammatory markers at the end of a clinical trial for a drug treating a current autoimmune condition. Shout out to my cronies out there. My Crohnsies? I guess it would be Crohnsies. All right, construct 90, 95, and 99% confidence interval for the true population proportion. So p-hat is 780. All right. 90%, we don't do that as much. It's just not strong. 95% is the standard one there. All right. There's a 95%. Notice that as we get more confident, the Mo rises. So there's a chance they could hit 80%. There is a chance they could hit 80%. So if they said like, hey, 80% of our folks are going to have symptom relief, it tested at 78. You might be like, Larry, pants on fire. But the upper bound is going above, And could they undoubtedly say that, or they say undoubtedly this is going to help 75% or more? Yeah, the lower bound is except for the 99%. We got to be careful. The lower bound for 90 and 95 is above 0.750, but it's not for the 99% confidence interval. Anyway, finish that one on 6. Okay, folks, this is Yak Math Videos signing out.